Hi, this is Kate from MinuteEarth. Until relatively recently, humans believed everything we could see in the sky was orbiting around the Earth. Of course, the moon was the only thing actually orbiting the Earth, and the Earth itself was orbiting a star. But there were other objects orbiting that star that also had things orbiting them, so we decided to call all of those secondary satellites moons too. Nowadays, when people say moon, they essentially mean a natural satellite of a star, which seems to capture our collective intuition for what distinguishes a moon. However, there's a problem. Space rocks come in all sorts of shapes and sizes and behave in many ways, many of which don't seem at all like our traditional idea of a moon. We could at this point give up and say, okay, all these things are moons. But in this video, we're gonna defend the idea that moon is a special title and we shouldn't award it too broadly. To start with, through improvements in technology, we've ended up calling smaller and smaller things moons. We've already identified more than 60 increasingly small moons orbiting Saturn alone, some of which are essentially kilometer-wide rocks hiding in its rings. It's inevitable that we'll keep identifying ever smaller individual chunks orbiting planets. So if we don't set some lower limit on moon sizes, are we willing to think of each of the billions of tiny rocks and dust particles in Saturn's rings, and every last speck of dust orbiting the Earth, as moons? At the other extreme, some moons are too big to be considered moons. Pluto and its maybe moon Charon are close enough in size that it's really fairer to say they both orbit each other. In fact, technically, anytime anything orbits any other thing, they're actually both orbiting their common center of mass, called the Barycenter. Where that point is depends on the relative masses of the two objects. If one is way bigger than the other, like the Earth, the Barycenter will be close to or even inside it, so it feels right to say that the smaller one is orbiting around the bigger one. But when they're almost the same size, like with the binary asteroid 90 Antiope, the Barycenter will be almost halfway between. And it really doesn't make sense to call one or the other, or both of them, moons. So where in the continuum of size ratios, aka who's really orbiting who and by how much, where should we stop calling something a moon? Maybe the ratio of sizes doesn't accurately capture your intuition about what a moon is. Maybe absolute size would be better, or the roundness of the candidate moon, or whether it can be seen from the surface of its planet, or whether it has a regular elliptical orbit. Or maybe there's simply no one definition for moon that captures both the complexity of the different ways that stuff can orbit other stuff, and our nebulous, intuitive, I know it when I see it idea of what makes a moon.
Unlike moons, there are many other objects in space, like the different things a star can become when it dies, that are actually delineated quite naturally, and you should come over to MinutePhysics to find out more about them. Enough of this, if there's a moon around a moon, is it still a moon? Come over to MinutePhysics, we're going to talk about black holes and white dwarfs and neutron stars.